So the problem I have chose to do for our quiz is problem number 6 on the chapter 22 homework. Let's get right into it. So you've got a disk, well, the problem reads, you've got a disk of radius 2.7 centimeters and has a surface charge density of 5.7 microcoulombs per meter squared on its upper face. What is the magnitude of the electric field produced by the disk at a point on its central axis at distance 16 centimeters from the disk? So it's basically like if you have your disk here, the point's going to be like out here, about 16 centimeters. So I think the best way to start with this problem is to list what we know and what we don't know, so the variables. What we do know, we know the charge density is given in the problem is 5.7 microcoulombs per meter squared. We know the radius of the disk is 2.7 centimeters or 0.027 meters. It's really important to use meters when you're solving for this problem. We know the distance of the desired point away from that disk on the central axis is 16 centimeters away or 0.16 meters. We also know what Coulomb's law constant is. We just learned that in class. What we don't know is we don't know what is Q is, so like the point charges, which will be used in the electric field formula. We also don't know the surface area of the disk at the moment, but that's super easy to calculate because we have radius, and yeah, you learned that in like geometry. So step 1, finding Q, or the point charge. Using the surface charge density formula, which I have written in red on this slide, you can find the point charge Q, which will be needed to calculate the magnitude of the electric field. And to do that, I have calculated the surface area, which is really easy. It's just radius squared times pi. And I got that to be 0.0023 meters squared. And now you can solve for the point charge in that surface charge density formula. You just isolate Q, and you'll just get the surface area times the density, which I have written out in red. And then from there, you can plug in the values that we know. We know what the surface area is. We know what the density is, and you got to make sure when you're using microcoulombs, micro is just 10 to the negative 6. And as you can see, I just plug that in right there, just the e to the negative 6. And that will solve for your point charge, which I got to be 1.305 times 10 to the negative 8 coulombs. So from there, we're pretty much, we're pretty much done. We just need to plug in values to the electric field formula, which I have written in red there. It's the electric field equals the Coulomb's law constant times the point charge divided by radius squared. We know what all of these variables are now. So once you plug those in at the bottom, as I've done there, and make sure you're using meters, not centimeters for that distance, you get a value for the magnitude of the electric field to be 4.63 times, well, about 4.6 times 10 to the third coulombs per newtons. And that's how you solve that problem. It's really, really simple. You just have to take two formulas, and using those two formulas, you actually have all the information you need to find the magnitude of the electric field. Thank you for watching. That's all.